So I'll start off with an introduction to Imagine if you're new to us. We offer discoveries and health checks. We have a wide range of services with a focus on optimizing your workflows and software usage. And then finally, we offer software training and support. We're part of RAND Worldwide, and that family includes Imagine It, RAND 3D, and Ascent. And you can see the various focuses of each company there on the slide. We have offices scattered around the US and Canada. Nearly all of them have techs like myself, and we're there to provide software support and solutions. So more than likely there's one somewhere near your office. This is a look at the different teams we have here and the services that we offer. Each one of these teams is a dedicated group of experts in that area. And then we have several types of training, in-person and the live online and custom classes. They have a dedicated instructor for the entire class, and the schedule can be set to fit your needs. I've done training where we did half days on Mondays and spread it out over several weeks. That's pretty close to the blended learning. That's kind of a semi-live type of training where you have a live instructor who introduces a topic, and then you're given some tasks offline, and then you meet back in a few days for Q&A and the introduction of the next topic, and then we have full web-based training as well. So we're the largest authorized Autodesk training center in North America, and Ascent creates our courseware. So that's all done in-house. And our implementation process, that take aim implementation methodology, is what we use for implementing various strategies or softwares that we found a need for during the discovery or health checks. And Productivity Now is the platform we use for tech support and online training. And I'm sure there have been WebExes on Productivity Now. We have a close partnership with a number of other companies other than Autodesk, all of them really with the goal to enhance your design workflows. And I should point out that Imagine It is listed there because we have a software development group as well that's created a number of software packages themselves that fill needs that we found while out in the field. And some of them are free to our customers, others are for purchase, but each one of them fills a unique need that we found in a typical engineering workflow. So a little bit about me. I'm fairly new to the reality capture team. I'm on the manufacturing team as well. I was brought into the reality capture team because of, really because of the BLK. At that low entry point into point cloud scanning kind of opened up a whole new world for the manufacturing group. Before it was pretty much architectural and civil, and questions have been coming in about Inventor, and they didn't have answers. So a few of us, Brady, myself, and Rusty are on the MSD team, and we're also on the reality capture team. So if you, and I'm sure you'll have some questions at the end on Inventor and point clouds or workflow issues that you've run up against, that's exactly what we've been put in place to try to find workarounds and proper practices for working with point clouds inside of Inventor and AutoCAD. So this is my slide deck. This is what I'm going to show. Point clouds in Inventor, how to deal with point clouds in drawings, and we'll talk about point clouds in the vault. So this is all really new. It's like every other week I seem to find some new piece of software that just came out that deals with a specific area of point clouds in the manufacturing workflow. So this is really, technology is really moving fast. It's kind of exciting to be a part of it. So that's it for slides. Let's jump into Inventor. I'm going to try to point out the scanners that were used as I come across the various scans. I think the scans that I bring up were done with the BLK, the RTC, and the P series. I'll try to point out which one was used for the various scans so you get an idea of what they look like between the different scanners. So first of all, the first topic there was just point clouds in Inventor, in an assembly and in a part. What can you do with them? So the very first thing that I scanned when I got my hands on a scanner was my house, and then sometime later decided that I needed to redo the back deck. And got towels around it because my kids just got back from the pool. Had I known I was going to be using the back deck, I would have moved them. But inside of Inventor, you can measure off of surfaces. It tries to find, so each one of the pieces of siding, it tries to find common points in a plane. If you play around, sometimes you can find, it'll average out over a larger area, and you'll get more of a flat surface instead of going across. There was one. Instead of going across all of the pieces of siding, since everyone's at a slightly different angle. So when you find one, I'll just go off of a piece of glass. I can come over to here, pick a point on my point cloud, and it tells me a distance, and then I can go off of another point, another plane, and it tells me the distance in the other direction off that point. So you can measure. This was done with the BLK360. I had a scan on the top, and I had a scan here and a scan here. So this one's, I'm going to guess that I probably had a 2 millimeter accuracy. But it's more than enough for me to pull measurements off of these various pieces of wood and figure out if that was a 2x4 or a 2x6 and start measuring or start building. So let me open this part up. What I found works best is inserting the point cloud into an IPT, and you just attach it. I've been using the RCS instead of the RCP. The RCP requires all of the support files from ReCap, and RCS is exported from the ReCap project, and it's just a single file. And it's much easier to manage in the Inventor workflow. So from the entire house scan, I cropped out just this section and saved it out as an RCS and brought it into Inventor with this attach option. And then to give myself some starting points, I placed planes. So you have two commands for referencing a point cloud. You can't select a point cloud. You can measure off of it, but you can't constrain to it, and you can't select it. So if there's a certain plane or a certain point that you want to select, you have to use one of these two commands. So this point cloud, I can come down here, and it finds the average around that point, and it's going to give me a plane. And now I have a plane at that point that I can reference in my assembly. So if you attach the point cloud in the assembly, you kind of lose the ability to go in and add geometry or add planes and add points for reference in the assembly. I think you have quite a bit more freedom if you do it as an IPT and then bring that IPT into the assembly. It doesn't embed the point cloud. It creates a link, so you still need that RCS file. So what I did with this one then, I just gave myself a bunch of landing planes. So I got a plane on the wall, a plane on this wall, a plane on the deck. Some of them I stretched, you know, like this one, I finally found one that was giving me a nice big average plane, and then I stretched it to be the proper size. And I gave myself a plane for every one of the step treads. Brought that into my assembly. And then in this case, since I know my standard sizes, I really just started doing measuring, modeling up my parts and constraining them into place. So if I turn all visibility on, this is my new deck. So I extended it out a couple feet, pulled a grill off of GrabCAD, and then in order to see it away from the other deck, the original deck, I created a new point cloud where I cropped out the original deck so I can see what this is going to look like, you know, without the old deck in place. So I have 2 point clouds in this assembly. It's a little tricky constraining sometimes because nothing is square in the real world, it seems. Even these posts, I did them as a pattern, but if you look at the points, they're not even close. The one in the back was off by like 8 degrees. So when you go to constrain, you usually use a face and then a point to one of your other planes and then a point to one of the other planes to try to get everything in place. You really can't do the standard Inventor, you know, mate, and face. It just doesn't work out. Let's see. I'll switch to this scan. This again was done with the BLK. Let me open up the original IPT. This was a really tough scan because this conference room table had about a 1/4 inch of clear on it. These benches had a bunch of clear on it, and I had glass. So I really didn't get that great of a scan here. But the goal here was to put some cabinetry in this corner and see what it would look like. But since we're going for more of a photo, I really needed to clean this up a little bit, fill in these holes where the shadows were left after I cut out the points that were the original shelf unit, and there was a little refrigerator right here. So just to show kind of what I did there, I referenced the lines that were on the floor here, and I modeled some glass. And then I filled in the walls. So I used one of the planes. Actually, I think I used the XY plane and just referenced the points to draw a wall and extruded that, tried to find a color that somewhat matches. Did the same thing on the floor, found a wood grain that kind of matched the wood grain that was there. The floor was really shiny and wasn't giving me good points. And then the tabletop. I used the plane, the average plane based off of points, and drew in a rectangle to fill in that table a little bit. So in the assembly, for some reason, Inventor's assembly lighting is slightly different from the part. I've never understood that, but in the assembly is where I was working, so I tried to find my colors in the assembly. It ended up pretty good. Filled in my circles here where I didn't get good points because the scanner was sitting there. And since I just referenced rectangles when I drew this, everything is actually at hard 90s. So this thing actually constrains quite well. I don't have to use points because I'm just referencing that geometry that I had in the back. Okay, there we go. Yeah, so that worked out with just plane, and plane, but a lot of times with point clouds, you might be able to get away with 2 planes, but then that third one you're going to have to go with a plane and a point in order to constrain it into place. So just to see the whole process for bringing something like this in, let's close some of this stuff. I'll bring in an engine into an empty IPT so you can see that workflow, and then I'll extract some points and off of one of the pipes. All right, new IPT. And off of the Manage tab, you have Attach. And I have an RCS single sample pump engine point cloud ready for insert. So it came right in. This is 6 million points. It came right in. I can drop it, insert it at origin. And since Z is up, my home view is never right. So usually I start off with setting my home view. I don't know why I don't just change that in the template. But if this is something that I want to have a pipe in an assembly constrain off of, you can start cleaning up the IPT here and referencing some of those points. I probably would create the plane on the flange, but I think it's more visible if I do it right here on the top. I can't use the point plane command because there is no, it's not going to find an average of points. It's not going to give me a plane, but I can extract an individual point. So I'll just find a point near the top. Over here, I'll find a point near the top. And so that I don't pick through it, I'll rotate and pick a point near the top. And 3 points defines a plane. So I can put a plane on there now. And I can put a sketch on the plane and reference those points. I think I got that one. Yeah, I did. And then I'll just constrain a circle to those points. And then you could model right off of this. Let's actually make it a pipe. So you could model directly from this if you were trying to redesign or finish out the design, but more than likely this is something that's going to go into an assembly. So something that's kind of nice to do, if that's the case, is extrude this just like 1/1000th of an inch or 1/8 of an inch. Turn off the visibility of all these, the work features. And now I have a cylinder that I can do. Hey, I had shift held on. Now I have a cylinder that I can constrain to with the insert command in the assembly, tied right into my point cloud. So you can grab any point and you can grab an average of points for a plane. I'm not sure how this is rotating. This is 6 million points, and this rotates as if it's a single IPT. I'm not sure how it's going across the web right now, but Inventor has no problem with this. To show something larger, I'll bring in, let's start a new part again, and I'll bring in an entire shop. This time I'll do an RCP so that I can show you the layers that you can toggle on and off from the RCP. There it is, RCP. So this is an actual recap project file. And if you were to try to check this assembly into the vault, it's going to require everything that's in this support folder as well. And this is, let's go to that folder and see how big it is. we can do that while this opens. This is 3.37 gig. All right, so I placed it. I'm going to put it at origin and say OK. So it's loading 3.7 gig into Inventor right now. I don't have a beast of a machine. My laptop's several years old. And I actually have 2 copies of Inventor running right now. And one of them is trying to update a drawing view. So that's not helping my process here. But it doesn't take very long. This is probably not what you're going to be doing, because this is not only bringing in what you see on the screen, the RCP is also bringing in all the stuff that I cropped out. So this is like all the points off in the distance. I think I have the floor turned off. In recap, you can select several points, and it'll select all the points in those in an average of that plane. So it's real easy to just select the floor and turn it off, and then just replace it with a work plane to limit the number of points. But right now, all of that's coming in. Let's see. Well, didn't take that long before I started the WebEx. So while that loads, let's talk point clouds in drawings. That's a question that I get about every third time I get involved with manufacturing, placing point clouds into an assembly. Because when you create your drawing views, the point clouds don't show up. So there's my factory. And if I go to my navigator, since this is an RCP, I can see all the stuff that I cropped out. I didn't delete it, I just cropped it out. So there's everything, and including the floor. So this is 7 gig that's loaded right now. And in this case, the client needed to see the roof to run piping through, but they also needed the floor, and it made it very difficult to work in this assembly, because in Inventor, you were constantly cropping in order to remove portions. Then you'd clear the crop, and then you would remove the portions just to try to work in this assembly. But it rotates pretty smooth, and it's a really large assembly, or a really large point cloud for Inventor to pull up. So that was a 3.7 gig, I think it was. If just this piece is saved out as an RCS, it is 1.9 gig. So I dropped a gig 0.7 off just by getting rid of those extra layers. But if I load this RCS, this navigator is blanked out because it's a single file, and it doesn't bring across those layers. It just brings across what you had in recap visible at that time. So that's one way to keep that file size down, especially if the end goal is to check this stuff into Vault, which is my last topic then. So I'm going to close out of that. And let's talk how we bring this stuff into drawings. So if I have a conveyor and a point cloud, and if I want to place that conveyor right here. But if I go to my drawing view, that conveyor is missing. So it's great for when I'm trying to work in the assembly, not so great when I try to create the drawing views. So if you only need a plan view, the easiest route is to attach your point cloud. So I'm going to attach a point cloud to that conveyor. And then you're going to put a sketch on the XY plane. And just draw your geometry on the XY plane. Okay, so there's my conveyor. And I'll put a sketch on the XY plane. I'll just draw some rectangles really quick. If you wanted it to be exact, you could have extracted points, projected the points down, and drawn lines from point to point to point. You could make that that shadow be really accurate. But I'll just eyeball this. Something like that. And I'm holding control so it doesn't add constraints other than coincident. I missed my line right there, didn't I? Yeah, I did. I'll do one more rectangle. You get what this one's actually at a little bit of an angle. I should probably do a 2-point rectangle for it, or a 3-point rectangle. And I missed miserably. That's too far off. Let's just stick with a 2-point. Okay. So this will show in the drawing, but you'll have to go to the IPT, make the sketch visible, and then say include the sketch. And you have to do that for every place that it's listed. But if instead you just do a boundary patch of all of those profiles, these surfaces will come across. It looks like I still didn't connect down there. Anyway, that's good enough. Let's save this. I'll just save it here, part 7, that's fine. So this is part 7, and we'll go to an assembly and bring that part in. So you could constrain it into place. You could use the geometry at the bottom to constrain it into place. You could have placed additional work planes or use the origin planes to get that constrained into place. And then if I create a drawing view of this, we can bring those surfaces in. So by default, surfaces don't come into your views. The easiest way to make that happen is just right-click on it and check visibility. And it brings everything in. So I don't have that positioned anywhere near where it's supposed to be. I'll put him there. There we go. So that's one way to get your point clouds into your drawing views. That's fine if you're only after plan views. If you need side views and front views, you can do that again on the other origin planes so that they show when you go to your plan in front. That still doesn't solve the issue if what you're modeling is a whole bunch of pipes coming into one area at various angles, and you want to reuse those pipes or show maybe an isometric of those pipes and how they connect. That floor plan and using the other two planes just isn't gonna work for you. You need the ability to see it in 3D more so on the IDW. So with Recap, you can export a point cloud and have it converted to a mesh. It sends it to the cloud. It costs Autodesk Cloud credits. It takes quite a while. Especially something really complex, you'll send it to the cloud, and it may be hours till you get an email that says that it's complete, and then you go download it. And to be honest, I think what I've been sending is too complex, because almost everything that I've sent has been pretty much useless. So 2 weeks ago, I was introduced to a piece of software that we sell that I was just unaware of, called 3D Reshaper. So this is 3D Reshaper. This is the point cloud of that engine. It's been brought in already. You just import a cloud into 3D Reshaper and select the cloud and say that you want to convert it to a mesh. Now, again, I've probably spent 8 hours in this piece of software. I have no training in it. From what I've seen, you can get some amazingly high detailed meshes out of it. I don't think that's what manufacturing is after, although I have been working on a really high detailed mesh of a seat, and if I have time, I'll pull that up. It's a curved 3D milled seat for a bar stool that I'm trying to take from a point cloud to a mesh and actually CNC it. And the plan is to actually CNC it and see what my accuracies are between them. So I haven't got that far. I'm not that great with this software, but you're able to extract edges out of this. It does a really great job, and then actually make the mesh snap to those edges. Anyway, this is the point cloud just to show the process. I think what general manufacturing is after is just a simple mesh so that they can throw it into their drawing. So if I leave this all default and hit preview, it takes, here's the bars going across. This is a whole lot quicker than sending it to the cloud. It would take longer than this to send your point cloud to the cloud, because you're sending, potentially 3 gig across the network. Just to get it there. And this is a mesh. It's done already. If I zoom in on it and show the mesh, you can see that's a mesh. I can save this as an OBJ or an STL, bring it into an IPT, allow it to convert. It takes a little bit to convert, but I then have an IPT that is a mesh that will show in my assembly. And the nice thing is the UCS is common between the point cloud and the mesh. So you can insert that IPT grounded at 0, and the mesh completely overlays the point cloud, and then you'll have that in your assembly. So playing with this a little bit, playing with the settings a little bit, and then there's a smooth option. There's a refine, where if you refine from the point cloud, it'll actually fill in additional points between the points. Really brings out the detail here. I think, by the way, this scan was done with one of the P-series scanners. I didn't do this scan. I think this is a P-series scan. But after playing with it a little bit, this is my mesh, which is not bad for someone who has no idea how to use 3D Reshaper. I think 3D Reshaper should be a webcast topic all by itself, because just in the little bit I've been playing around with it, I've found all kinds of additional options that I think would really help us simplify some of this. So this is, let me see, I wrote it down. This is 1.2 million faces. That's what you're looking at right now. But when I just did that simple convert, just using the defaults, and then did a smooth to it, I took that into Recap and simplified the mesh. Recap Photo lets you really quickly simplify a mesh. I'm sure you can do it in this software as well. I just don't know how. But there's a smooth option here. So I ran one iteration of smoothing, much simpler mesh. And then in recap, I simplified it even more. I brought it all the way down to 120,000 faces. So I took it from 1.2 million to 120,000. And after seeing it in the drawing, I think I could have cut that to a quarter of that yet and been happy with my results. So once you're done, you select the mesh, export it as an OBJ or a STL, and then you bring it into Inventor. So once I have that converted in Inventor, let's close you. Let's leave him up for now. This is why my computer is not running well, right here. This is the 120,000 face mesh, a drawing view of it. This is the 1.2 million face mesh, and it has been working on generating this view for 3.5 to 4 hours. I mean, if you look, my Inventor is maxing out a core or two working on this right now. Just trying to generate that. Initially I had a front, top, and side view and left it overnight, and the ISO view and 2 of the side views were done, but it was still working on one of the others. So you definitely want a simplified mesh. If I take that into an assembly, which actually I think I have an assembly with it in already, I'll be able to create a drawing view and show you that mesh already showing up in the drawing view. Sample shop. Nope, it's the engine. I don't remember where I saved that assembly. You know what? I just thought of where it's at. It's in here. Yeah, this is it. So here's a sample assembly that has that engine in it as a mesh, and I can create a drawing view of it. Of course, all while I have a view trying to generate in the background, so everything's kind of running a little bit slow. So there's the assembly with the mesh in it. This actually is the 1.2 million mesh. But if I create a drawing view of that, actually, let's just go to my drawing. Create a new sheet. This is going to behave the same way. After I place it, I'm going to have to go turn the visibility on in order to transfer. Oops. In order to transfer the mesh. So if I just click on visibility, it'll turn everything visible, and my mesh part will come in now. So now I have 2 views trying to generate. So I think that's the answer that people are looking for on how do I bring my point clouds into Inventor. I think the answer, until Autodesk gives us the ability to display points in Inventor, the simplest solution is going to be a 3D reshaper. It will take a really complex assembly and very quickly turn it into a mesh. And that mesh, by the way, you would think would be really big. Just for comparison's sake here, I'll show you. If I go to the sample pump room, here's the RCS. That's 212 meg. That's the point cloud. And this is the 1.2 million faces object. Well, actually, that's before it got converted to an IPT. That's the OBJ. So it's 24 meg once it's converted to an IPT. And then this one is after I simplified it down to 120K faces. It's 2 meg. So that right there is a 212 meg point cloud brought down to 1.9 meg, and it displays in my drawing. So I think 3D Reshaper is going to be huge, and it's definitely on my to-do list to learn and figure out how we can bring it more into the manufacturing workflow. So hopefully in the near future I can do a presentation on 3D Reshaper, but I think that's where I'll have to cut this one off now. So let me close this drawing so my inventor can breathe again. And let's talk about Vault. Time do I got? 1:42. Let's talk about Vault. So doesn't want to close. Oh, do you wish to continue closing? Yes. Do you want to save? No. Now I see why it didn't close. I'm going to go back to this really large factory layout and talk about how we would bring that into Vault. So this layout. So I forget how big it was. This was 3.37 gig, and we need to bring this into the Vault. So if you have to bring in a file that's many gigs, I think the workflow that I'm going to recommend is you create rules in your Vault so that on check-in, the RCSs immediately go to released. The RCP doesn't have to, and then you would still be able to open that in Recap and add layers, add additional views. That looks like that only changes the RCP. Now, if you delete a point or select a series of points and press delete, that actually modifies the RCS, and that the RCSs are the big files. The RCP in this case, the project file itself, 87K. The only thing that it's keeping track of is the registration of the RCSs that are in the support folder and the layers, the visibilities that you've set, and the orientation, where 00 is, that type of thing. That's all that's really being saved here. But if I go into the support and look at the RCSs, that's where you'll see they're a gig, a gig and a quarter each. Oh, it's actually reading the BLKs. Okay, yeah, so here's my RCS. So I have the original scans. I don't know what, no, those aren't BLKs. Those are backups from deletes or something. I'm not actually sure what that file extension is, but this is my RCS. This is the combination. So this has already been unified into one sketch inside of Recap. It's no longer individuals. Otherwise, you'd see a bunch of RCSs for all of the scans through this thing. This is the file that when you delete points gets changed. So you should set a rule that makes RCSs check into Vault automatically released, and I wouldn't even give them another life cycle. They just check in as released, and if someone wants to modify it, then you need to delete the entire thing and check it in again. You'll break your links to Inventor, but that can be easily recreated the next time you open the Inventor assembly or part. Just so that, if someone goes in to maybe save space and they delete, this piece right here is not needed, so they delete it. Well, they saved 20K, but they just duplicated 3.5 gig in your vault. Every time that comes and goes with a change, it's adding another 3.5 gig to your vault in this case. So anyway, that's my workflow if the entire thing needs to go in. And I kind of happened upon something with this client where we needed the floor and we also needed the roof, and it made it very difficult to see down inside of it. We also wanted to check the files in the vault. Weren't really sure how they were going to handle that with the file size that was going to be coming and going. What we did for them was inside of Recap, we used the box crop and we created slices. And some slices this way, a slice of the floor. And we took 6.7 gig, and we turned that into, by saving out slices of slice RCS files. So here's my RCS 1 through 7, with an extra one in there. And I'm looking at, out of those 11 slices, I'm looking at 270 meg as opposed to 2 gig. Had I really been careful with how I sliced it, and then after I sliced it, went in and removed stuff that wasn't necessarily inside of the slice, I could have easily cut this in half, maybe even better. So how that works then to bring them all together, I'll start a new part. And I'll just start placing those RCS files. So, and since they all share a common 00, they go in really easily. Let's make sure it's an RCS. So I think that was my first one, 77 meg. I'm not sure what that one is. Let's bring him in first. And I'll just say insert at origin. All right, so it looks like that's the floor. If I would have cut that height in half, I could have cut the file size in half on this one. And then I'll attach the rest of the slices. So there's one. So he's over here. There's a couple structural pieces up top. I've cut everything out of the middle, it looks like, or that was all just hollow anyway. There's another one. And I'll just keep doing it. So there's 3. So I got 2 sections in there. That one went down here. So 3 gig, over 3 gig has been reduced to 200 meg. And I think the next one goes the other direction, if I remember right. Yep. And there's one last one. I'm going to place this into an assembly. And I have everything that I need to work with in order to run whatever ductwork I was after. I can see all of my pipes running through here. Go to the next section, I can see my pipes. Go to the next section, I can see my pipes. If you wanted it to be really accurate, in their case, they would take one pipe, get the circle, get the other circle, and they would just loft between the two. But if you really wanted it accurate, you could do every section, do a circle for every section, and loft between sections, and you would have a pretty accurate part without the massive file size that would come with having the entire thing loaded. So I was going to save this and insert the conveyor. Let's do it. We'll save him as part 9, start an assembly, and insert him. And then we'll bring that conveyor in, because that conveyor actually came from this assembly. So There's my factory, and then I'll place, I think it was part 7. Yep. Open. And they should share a common 0, 0. Oh, they don't. It might. Let's see. XZ. XZ. Anyway, I should be able to just constrain him into place. So apply and why doesn't that work? These planes are too tiny. Yeah, that's the one I want. Huh. Anyway, it goes right here. So let's put the XY on the XY, and then I'll be quiet and let you guys ask questions. I may have picked the plane wrong last time. And the final one would be that plane to that plane. So it's off a little bit. So let's push it over an inch, maybe 1.5. That's pretty close. So I have it as a separate part, but brought into my assembly, but put back into place right where it was at. So anyway, this whole thing checks into Vault and is only 200 meg instead of many gigs. So I'll be quiet and see what questions you have. That gives us not quite 10 minutes, but